Lesson 408, Secants and Tangents, Part 1. The objectives of this lesson, you're going to find the measures of angles formed by intersecting tangents and secants. You'll also find the measures of intercepted arcs formed by intersecting tangents and secants. And you will use the relationship between the measures of angles and arcs formed by intersecting chords to find missing measures. We've learned in previous lessons about angles formed by two chords of a circle and its vertex was on the circle. Now we're going to consider other possibilities involving tangents, secants, and chords. This figure shows an angle whose vertex lies on the circle. It may be formed by a chord, such as segment AD, or secant, which is line AD, and a tangent line AB. And you can see the angle that's formed right here. This figure shows that an angle, such as angle BDE, formed by two chords of a circle, will have its vertex in the interior of a circle instead of on the circle. If we replace a chord with a secant line, the measure of the angle is still equal to 1/2 the measure of its intercepted arc. That measure is not going to change. As the endpoint of the arc contained in the secant line moves closer to the vertex of the inscribed angle, the relationship between the measure of angle BDA equals 1/2 the measure of arc AB. That continues to hold true. So let's determine the measure of angle EDA if the measure of arc AD is 146. Well, you want to start out by writing out your problem because that helps us understand. Well, first, what you've got to do is turn on your pen so you don't change the slides. Okay, a little bit of comic relief. All right, what we're going to write is the measure of angle EDA equals 1/2 the measure of arc AD. Okay, we don't know the measure of EDA. That's what we want to find out. So I'm just going to write that down again. I should just call it X, but I guess I like writing today. The measure of arc AD is 146 degrees. So the measure of angle EDA is going to be 146 divided by 2, which is going to give you 73. So remember, we've seen in figures in the past where they mark that measure of the angle with X degrees and they mark the arc with 2X degrees. That's how we know that if we divide the arc by 2, we're going to get the measure of the angle. This one says, determine the measure of angle EDA if AFD, or the measure of major arc AFD, is 225. So I'm going to write 225 down here. That's this whole arc going from D on around through F up here to A. Okay, that's a pretty big arc. Well, I look here, I know the whole circle is 225 degrees. So if I say 360 minus 225, I'm going to get 135 degrees. So I know that this arc right here is 135 degrees. So if I want to know the measure of angle EDA, I know it's going to equal 1/2 the measure of arc AD. Oh, forgot my little M. Pretend like it is there. So I just figured out up here that the measure of arc AD is 135. So 135 divided by 2 is going to give me 67.5 degrees. So that's what this angle right here measures. Okay, now they want me to determine the measure of arc DA, which goes just from right here, so it's a little minor arc. But they told me that the measure of the angle is 60. Now, because the measure of the angle is equal to 1/2 the measure of the intercepted arc, we can also say that the measure of the arc is equal to twice the measure of the angle. So remember, x degrees to x degrees. And that's right there is equal. So I can say the measure of angle EDA, well, let me write this different. The measure of arc DA equals 2 times the measure of angle EDA. So the measure of the arc DA equals 2 times 60. So the measure of arc DA, make sure it's an arc, it doesn't look like a segment, is going to be 120 degrees. Okay, here they want to know the measure of the major arc, DFA, and that's the one that goes all the way around, just like I'm drawing here, okay? They want to know what that measure is based on the fact that this angle right here equals 80 degrees. Well, remember how we set that up? 80 is going to equal x, so that means this arc right here is 2 times x degrees. So I'm going to say, so I got to figure out the measure of arc AD. So measure of AD, arc AD, equals 2 times the measure of angle EDA. So the measure of arc AD equals 2 times 80, which gives me 160. Okay, now remember, the circle's 360 degrees. 360 minus 160 is going to give me 200. So the measure of the major arc, DFA, is going to equal 200 degrees. Okay, the inscribed angle theorem helps you solve for angles and arcs when the vertex lies on the circle. For each angle in the pair of vertical angles, the measure is 1/2 the sum of the arcs intercepted by the angles. So let me write this out for you. It makes it a little easier to grasp. Okay, says for each angle, so right now I'm going to be focusing on the angle EFB, FEB, which is right here, okay? If I wanted to find the measure of that angle, I would say the measure of angle FEB equals half the measure, okay, remember this, half the measure, 1/2 the sum of the arcs intercepted by the angles. Okay, so look at this. It's going to be half the sum of arc FB plus, because remember sum means you're adding together, arc AD. So I'm going to take the measure of these two arcs right here. I'm going to add them together and divide by 2. That'll tell me what the measure of those arcs are. Now if I wanted to know the measure of AEF or DEB, you're going to do it the same way. I would say the measure of angle AEF equals half the sum of its intercepted arcs. So that would say measure of arc AF, I bet I'm going to run out of screen, so I'm going to write this down here at the bottom, plus the measure of arc DB. Close those parentheses right there. Okay, so let's see an example. Okay, they says the arc FB is 42 degrees, and this is a good example of why you never go by what the picture looks like, because that is definitely bigger than 42 degrees. And the measure of arc AD is 58 degrees, which definitely is not 58. Okay, so don't go by the picture. Just do what the problem tells you. Okay, we want to know, what is the measure of angle AED? Well, we learned that if we take half the sum of its intercepted arcs, so that's going to be the measure of arc AD plus the measure of arc FB. There we go. So AED, angle AED, is going to equal half. AD is 58, FB is 42. Those two numbers added together is going to give me 100. So the measure of angle AED is going to equal half of 100, which is 50 degrees. AED, 50 degrees. So that means this one here is 50 degrees. And if they wanted you to solve the other two angles, remember a straight line is 180 degrees. So these guys would be 130 degrees. Okay, so here they said the measure of AEF, angle AEF, is 120 degrees. Vertical angles are always congruent. The measure of arc DB, where is DB? Woo, it's 150 degrees. What is the measure of arc AD? That's what they want to know right there. So you're like, wow, we've got to go the long way around to find this one. Okay, measure of angle AEF is going to equal half the sum of the intercepted arcs. So we're going to have the measure of arc AF plus the measure of arc DB. Okay, so we know that the measure of angle AEF is 120. We know the measure of arc AF is unknown, so we're going to put AF there, plus DB is 150. And now what we're going to do before we start trying to figure all this out, we're going to get rid of this fraction. And remember, to do that, I multiply both sides by the denominator. So I'm going to have 2 times 120 is 240. And then these 2's reduce to 1. So I'm going to be left with the measure of arc AF plus 150. And I believe this is supposed to be an F up here. That's not supposed to be AD. So we're wanting to know the measure of this angle, not this, arc, not that one over there. Okay, so now I'm going to subtract 150 from both sides. So that's going to give me 90 equals the measure of arc AF. Alright, so in today's lesson, you've learned that the measure of an angle formed by a tangent in a chord or a secant is equal to 1/2 the measure of its intercepted arc if the vertex of the angle lies on the circle. You learned that the measure of an angle formed by two chords intersecting in the interior of a circle is equal to 1/2 the sum of the measure of the arc intercepted by the angle and the arc intercepted by its vertical angle. After you watch this video, you should go to your LMS, lesson 408, Secants and Tangents. Go through the lesson, complete your student guide. Also read the lesson and the reference guide, add any additional notes. Then complete problems 1 through 7 odd in your problem set. And if you don't understand the concepts after doing these steps, that's when you need to contact me or attend TOGA if you have any questions before you complete the 4.08 quiz. And make note of any general questions you may have when you attend CC. Oops. Okay, and also whenever you do contact me with questions, please give me your course and section number so that way I can help you faster. That's going to be it for lesson 408. Thanks for listening.